So on partial pressures, you're not going to use the PV equals nRT. Instead, we're going to use P total equals P1 plus P2 plus P3, however many partial pressures there are. You have to have at least 2. You don't have to have 3, and you could have an infinite number, but you won't ever with this. So this is our formula. PV equals nRT is not part of this. We are only concerned about pressures. So our pressure units are either going to be mmHg, kPa, or atmospheres. And you can use any 3 of these, but in one problem, they all have to match. So if you start a problem with mmHg, they all have to be mmHg. If you have a problem that has mmHg and kPa, you have to convert one of them to the other. I'm looking at this problem, the number 2 on partial pressures that you have. The one that says a 22.4 liter glass bulb has a total pressure of 760 millimeters of mercury. So in that problem, they've given you a lot of extra information. They gave you the 22.4 liters, completely irrelevant. We don't need that, and we don't need temperature. We only care about pressures. So we see that this one is all in millimeters of mercury. And in the first sentence, it says the glass bulb has a total pressure of 760 millimeters of mercury. So P total equals 760 millimeters of mercury. We're also going to be looking for P1, P2, and P3. So the very next pressure that they give us is going to be a partial pressure. So it says if the partial pressure of nitrogen is 250 millimeters of mercury, so that's going to be our P1, 250 millimeters of mercury. It's just whatever one they give us first will be P1. It really doesn't matter which order you put them in. And then it continues and says, and the partial pressure of argon is 130. So we're going to let that be our P2, 130 millimeters of mercury. And this problem is really good because they're all in the same unit, so we don't have to do any kind of converting. And then it says, what is the partial pressure of helium in the tank? So helium would be our P3, and that's what we're looking for. We're looking for P3. So we're just going to set this up and put it into our formula. So P total equals 760 millimeters of mercury. And I'm just pulling this straight from the formula. So P total equals P1, which is 250 millimeters of mercury. And then we're going to go plus P2, which is 130 millimeters of mercury. And then we're going to do plus P3, since that's what we're looking for. And just like with all the other formulas, we want to get our variable all by itself. So we'll do the opposite function. Since we're adding on this side, and we want to get P3 all by itself on this side, we want to do the opposite function of what's happening, which would be subtraction. So we're going to subtract both sides by 250 and 130. So whatever we do on one side, we have to do to the other side of the equation. So we're also going to subtract 250 and 130 on this side. And once we do that, that will give us our answer. We get P3, because that's what's left over, equals 380 millimeters of mercury. And that's our answer.